Okay, on to 10.4, dealing with quadratic equations now. And first question here, number 4, has to do with finding the vertex of a quadratic equation. So remember, the vertex is quadratic equations are either going to look like this or they're going to look like this, right? Depending on what the value in front of the x squared term is. If the value in front of the x squared term is negative, then it's going to look like this. If the value in front of the x squared term is positive, then it's going to look like this. This top point or bottom point, those are called the vertices or the vertex. This is the vertex of this quadratic parabola. This point at the bottom is the vertex in that direction. So to find that, the x-coordinate of the vertex is going to be negative b over 2a. And remember, where we're getting these a's and b's, we're using the general form of a quadratic, which is this, right? So the a is the number in front of the x squared term. In this case, a is -1. The b is the number in front of the x to the first term. Well, there is no x to the first term here, so that b term is going to be 0. Right? So in this case, a is going to be -1 and b is going to be 0. So the x-coordinate of the vertex here, negative b, well, 0 over anything is going to be 0. So that's the x-coordinate of the vertex. Now all we do to find the y-coordinate is put that x-coordinate into the function or into the equation. Right? So when x is 0, y is going to be 0 plus 3, or 3. So there we go. There's our vertex. Our vertex is at the point 0, 3. And that's how you find the vertex of any quadratic equation. It has to be in this form. Once you have it in this form, you identify the a and the b is all you need. You don't need the c. The c here is 3, but that doesn't factor into our calculations. The c does factor into our calculations for x-intercepts, which we'll do in a minute. But for the vertex, you form the x-coordinate using this ratio, negative b over 2a, and then you put that x value into the equation to find the y value, and that's going to be your vertex at the point 0, 3. And if you plug this into your calculator, you can check and make sure that that is the actual vertex. All right, so now when we're asked to find x and y intercepts, remember we've talked about x, well here we're just looking for x-intercepts. So we talked about every x-intercept has a y value of 0. So we got to set y equal to 0 to find the x-intercepts. So we're going to set y equal to 0, and now we have this equation. And we're going to solve this for x. So we did this in chapter 9 also. Remember, if we can factor, then we always try to factor first. Well, factors of 3 and 1, think, okay, maybe I can get a 4 out of that. But since it's negative, one of the numbers has to be negative and one has to be positive, right? If you were to try to factor this, you'd have x and x, and you'd think 3 and 1, but there's no way I can make this product, the L term of the FOIL, be -3, and then the sum be a +4. So factoring is not going to be an option in this case. So we are forced to go with the famous quadratic formula. So we know that using the quadratic formula and identifying our a, b, and c first, so our a, b, and c here, our a is 1, our b is 4, and our c is -3. Right? The values in front of x squared, in front of x, and the constant term c. So once we do that, we know that we can solve using this formula, quadratic formula. So it's just a matter of being careful now and plugging in the numbers, paying attention to details, all of that stuff. So here we'll get -b plus and minus b squared minus 4ac over 2 times a. And we just continue carefully calculating this value. Underneath the square root, be very careful here. Remember your order of operations. You're subtracting this entire product. Multiplication comes before subtraction. So we're subtracting a -12 here. So we're adding 12 to this 16. 4 squared is 16. We're adding 12. We're dividing everything by 2. We keep going. We can split this up into 2 fractions. -4 over 2 just becomes a -2. And this is the square root of 28 over 2. And we always want to simplify as much as possible. So when we get this -4 over 2, we can just say that's -2. And we want to simplify that radical if we can. If we can find a factor of 28 that's a perfect square, such as 4, 4 times 7, we can write, if we go over to the side here, we can see that we can reduce the square root of 28 by looking at it as the square root of 4 times 7, because we know that when we have the square root of a product of 2 values, we can split that up into the product of those individual square roots. We took the 4 out because we know the square root of 4 is 2. So we end up with 2 root 7. So I can change the square root of 28 to 2 root 7 using this process. So that's what I'm doing here. Square root of 28 becomes 2 root 7 over 2. Those 2's cancel out. So I'm left with -2 plus and minus square root of 7. And those are the x values of my x-intercepts. So my x-intercepts, just to be complete, my x-intercepts are at -2 plus root 7, 0, and -2 minus root 7, 0. And that would be your answer to this question here, number 18. Find the x-intercepts of that quadratic equation. And again, you can check this, put this into your calculator, use the trace function to see if those are the x-intercepts on the graph of that function. All right, so vertex x-intercepts of quadratics.